In this video, we are going to talk about polyprotic acids and percent dissociation. So a polyprotic acid has more than one ionizable proton. So I say more than one ionizable proton because there's a lot of compounds that have hydrogen, but they're not ionizable. So for example, if you have something like CH3, COOH, then some of these hydrogens we can ionize, meaning we can take it off. Some of them we can't. So the three hydrogens connected to the carbon are not ionizable. The only ionizable proton here is the hydrogen connected to the oxygen, and that is because it is a very polar bond. So in order to be ionizable, we have to have a polar bond. Now, if you have more than one ionizable proton, that means you're going to have a Ka value for each proton that is dissociated. So let's look at an example, and we can look at phosphoric acid. So with phosphoric acid, we can ask ourselves, how many hydrogens do we have? How many ionizable protons do we have? And the answer is 3. That's because we have 3 hydrogens right here. So that also means that we're going to have 3 Ka values, one for each proton that is ionizable. So remember, to get your overall K, you have to do K1 times K2 times K3, etc., for however many Ks you have. So when we set this up, we can have phosphoric acid plus water will exist in equilibrium. My acid is going to be donating a proton, and my base is going to be accepting it. So in this case, water is going to be accepting a proton, and my phosphoric acid is going to be donating a proton. So this right here is going to be my Ka1. Now I can take my dihydrogen phosphate and go through the same process. And water is going to accept the proton to become hydronium ion, and then we will get monohydrogen phosphate, and that will give me my Ka2. So far I've taken off 2 of my protons. I can use my monohydrogen phosphate and water to take off my 3rd proton, and that will give me my Ka3. Now, when you're going and looking at the overall equation, remember, if you have something on both sides of the equations, when we're adding these up, you can cancel them out. So I can cancel out my dihydrogen phosphate, and I can cancel out my monohydrogen phosphate. So that when I add these together, I'm going to get phosphoric acid plus 3 waters in equilibrium with 3 hydronium ions plus phosphate. And my K overall is going to be equal to the concentration of hydronium ion cubed times the concentration of phosphate, because those are my products, divided by the concentration of my reactants. And remember, we do not include water in our equilibrium expression. Now, if we want to look at why we multiply these together, if I get the equilibrium expressions for each of my individual steps, we're going to have the concentration of hydronium ion times the concentration of dihydrogen phosphate divided by the concentration of our phosphoric acid. That is terrible. We will rewrite that. And then I can do the same thing for my second one. So we'll have hydronium ion times monohydrogen phosphate over dihydrogen phosphate. And then finally, I can do it for my third one. We'll have hydronium ion and phosphate as our products. And we will have monohydrogen phosphate as our reactant. So you can see if I multiply these together, then I'm going to be canceling out dihydrogen phosphate because it's on the top and the bottom. I'll cancel out monohydrogen phosphate because it's on the top and the bottom. And when I multiply those together, I get this right here. All right, and so that's why we multiply them all together. Now, when we are talking about the percent dissociation, it is talking about how much of that proton leaves the acid. So remember, these exist in equilibrium. So that proton isn't 100% dissociating from the acid. And we can calculate that by using the percent dissociated is equal to the concentration of the acid that has dissociated divided by your initial concentration of your acid. And then because this is a percentage, we multiply it by 100. Now, if we look at this mathematically, as the initial concentration of the acid decreases, the percent dissociation is going to increase.